Hello and welcome to Engineering Simple. So this is part 5 of limits. So now we can deal with some absolute values. So we're trying to evaluate the limit of the absolute value of x as x approaches 0 minus. So 0 minus basically if you plot it, so you have 0 here. So basically this is x axis, this is the y axis. So x basically negative is to the left of 0 basically, which means it's more negative. So the absolute value of x is equal to x or minus x. It's equal to x if x is positive or minus x if x is negative. So 0 minus meaning basically this here. That means x is more negative. So I can write this as, so I can write limit, but I'm just going to write basically the absolute value of x. I can get rid of the absolute value. Basically it's negative x. Then I'm just going to replace x with 0. So minus 0 is just 0. But in other examples, as we'll see in the future, this here, this is important to know, that the meaning of 0 negative versus 0 positive. But for now, it's more of an introduction. Just kind of get familiar with the concept of 0 negative and 0 minus. So 0 plus just means if you take 0, basically it's to the right, so it's more positive. That means the absolute value of x is basically x. So you can write just x, then replace x with 0 is just 0. So here's another example. So limit of the absolute value of x minus 1 as x is approaching 1 minus. So again, if you plot this, so you have, here's the x-axis, here's the y. So if you have this is 1, so 1 minus basically it's to the left. So basically it's negative. So in general, if you have absolute value of x minus 1, so it can take two values. So x minus 1 if x minus 1 is positive, or minus quantity x minus 1 if x minus 1 is negative. In other words, so this here, if you solve this inequality here, x minus 1, you can move 1 to the other side, which becomes just 1. So x is greater than 1. And this here becomes x is less than 1. So 1 negative means x is less than 1, which means this here. So then I'm just going to write minus x minus 1, then minus, then I'll just replace x with 1. So it's just 0 basically. So plus just 1 plus just means it's to the left of 1, which means x is greater than 1, which is this case here, which is x minus 1. So this here, just x minus 1, then replace x with 1. 1 minus 1 is 0. Again, this concept of 1 plus or 1 minus will become more important in other videos where you evaluate the limit. And for instance, let's assume you have x minus 1. If you replace x with 1, it's going to give you 0. But then if it's to the right of 1 means it's 0 positive. 1 over 0 positive is just plus infinity. or infinity basically. But basically this here just on the introduction, just kind of understand the concept of 1 minus 1 plus, or to the right of 1 to the left of 1. Kind of the same thing here. So I have 2x minus 1. So the absolute value of 2x minus 1 is equal to x minus 1 if whatever is inside the absolute value is positive, and it's minus 2x minus 1 if whatever is inside the absolute value is negative. So if you solve this inequality, you will get x is greater than 1/2, and the same thing here, it's x less than 1/2. So basically, since again, if you plot this, so I have 1/2 here somewhere, so 1/2 plus just means to the right of 1/2, which means x is greater than 1/2, which means this here evaluates to 2x minus 1. So then just replace x with 1/2, because I have 1/2 here. For now, the plus doesn't matter, but again, in other cases, it will matter. Because if you get 0, is it 0 minus or 0 positive? Because that will determine if it's negative infinity or infinity. But anyway, 2 times 1/2 minus 1. So 2 times 1/2 is just 1 minus 1, which evaluates to 0. Again, this happens to be 0. In this case, it doesn't matter. But if it was 1 divided by 0, then is it 0 negative or 0 positive? Because that's what will determine if it evaluates to negative infinity or infinity. So here's another example. So first of all, again, it's important to notice this can be rewritten in the form of an identity. So we have the identity a squared minus 2 times a times b plus b squared, which is a minus b quantity squared. So if I take x squared is already squared minus 2 times something would give me 2x. So it's 2 times x times 1 give me 2x plus 1, which is the same as 1 squared. So I notice my a is x, my b is 1. So this limit here, and you can write this if you want, or just write the quantities. So x squared minus 2x plus 1, I can just replace it with x minus 1 quantity squared. In this case, we know this here is always positive because something that's squared is always positive. So I can just rewrite it as the limit of x as limit of x minus 1 squared as x approaches 1. Because in this case, I did not evaluate the absolute value like in two ways, because since the square of something is always positive regardless of the sign, so that's why I took advantage of that. Then you just replace x with 1, so 1 divided minus 1 squared, so it's 1 minus 1 is 0, squared is just 0. But again, it's important to notice this is an identity and it can be rewritten in the form of that identity, because we'll see in other complex limits where that will help in evaluating the limit. So again, So as x is approaching 2, so I have 2 here. This is the x-axis. So 2 plus, which means it's to the right, so in this direction, which means x is greater than 2. So so this is here is kind of similar to x is approaching 2 positive. 2 positive means x is greater than 2, and we know what's inside the square root, it will be always positive, because if you replace x with 2 with anything that's greater than 2, it will always be positive. So in this case, I'll just go ahead and replace x with 2. In other words, square root of 8, or if you don't like that, you can write 2 square root of 2, because 8 is 2 times 4. Square root of 4 is 2, and you end up with 2 square root of 2. Because, again, I went ahead and evaluated this limit by replacing x with 2, because it's x is greater than 2. If it was 2 minus, it would be different, because you're talking to the x is to the left, which means it will get negative. So notice here, so the absolute value of 2 times x squared plus 4, 2 which is positive times the square, we know this is positive, plus is positive, 4 is positive. So really this here can be just written as 2 times 2x squared plus 4, because this entire thing is positive, so we don't have to worry about the sign. Then you just replace x with 2. 2 times 2 squared is 4, plus 4. 2 times 4 is 8, plus 4 is 12. So what the takeaway from this is, you need to notice that if something is positive that's inside the absolute value, you don't have to say like we did before. We said x, the absolute value of x. There are two cases. It's x or negative x. It's x if x is positive, and it's negative x if x is negative. In this case, since this is positive, there's only one case. It's always equal to this. So the same thing here. So x squared, I'm just going to take what's inside the square. So x squared minus 4x plus 4. I'm going to write it in the form of the identity a squared minus 2ab plus b squared, which is just a minus b squared. So x squared minus, so I have 2 here. So I'm going to do 2 times something will give me 4x, so that's 2x plus 4, which is just 2 squared. So I notice that my a is x and b is 2, so squared. So this here can be written as the limit of square root of x minus 2 squared. Since this is squared, so it's always positive, so I can go ahead and get rid of square root of the square root sign, so it's just x minus 2. Then just replace x with 2, which is 2 minus 2, which is just 0. So the takeaway here, you notice that this is always positive. That's why I got rid of the square root. So that was it for this video. Thank you and have a great day.